So the topic of today's lesson is properties of trapezoid and kites. And our objective, I can use properties of trapezoids and kites to identify them and to distinguish them from other quadrilaterals. Just a quick refresher, trapezoid, the parts of a trapezoid are our two bases and our legs, and then also our two sets of base angles right here and here, and then angle B and angle C. And an isosceles trapezoid we have here has two congruent legs. So now a couple of theorems, and these are only for isosceles trapezoids. Okay, so keep that in mind. Only for isosceles trapezoids. So these legs are congruent. So if a trapezoid is isosceles, then each pair of base angles are congruent. So this angle is congruent to this angle, and then these two angles are congruent. Next, if a trapezoid has a pair of congruent base angles, then it is an isosceles trapezoid. So if it either has this pair of congruent base angles or this pair, either one, then we can say that the trapezoid is isosceles. And lastly, and again this one is only for isosceles trapezoids, trapezoid is isosceles if and only if its diagonals are congruent. So if we were to make our diagonals we can say that they are congruent. So you know that this diagonal is congruent to this diagonal. And then we can also say that our two legs are congruent because it is isosceles. Okay, the mid-segment of a trapezoid. And this theorem applies to all trapezoids, not just isosceles now. The theorem states that the mid-segment of a trapezoid is parallel to each base, and its length is 1/2 the sum of the length of the bases. So the mid-segment would be something about right here, and it is parallel to both bases, so all three of these are parallel, and its length is 1/2 the sum of the bases. So if we call this base 1 and this base 2, then the length of our mid-segment equals 1/2 of base 1 plus base 2. So let's do an example of that. So we want to find the length of mid-segment MN. And we know PQ is 12 and SR is 28. So to find this, we simply add 12 plus 28, and we're going to multiply that by 1/2. 12 plus 28 is 40, and 40 times 1/2 is 20, and we are in inches, so 20 inches. Moving on to kites, we have two theorems here. If a quadrilateral is a kite, then its diagonals are perpendicular to each other. So if we put our diagonals in here, then we can say that these diagonals are perpendicular, and if they are perpendicular, then they create right angles, and all four of these angles would be right angles. Our second theorem: if a quadrilateral is a kite, then exactly one of the pairs of opposite angles are congruent. So if we draw a kite here, the best of our ability, let's try that again. Then we can say exactly one of the pairs of opposite angles are congruent. So if we say that these are two congruent sides, then either this pair of opposite angles are congruent or this pair of opposite angles are congruent, but only one of the pairs. If we are going to use these two, then these two angles can't be congruent. So if WXYZ is a kite, we're going to find the distance of these four segments rounded to the nearest hundredth. So if we start with XY, and if this is a kite, we can say that these are all right angles because our diagonals are perpendicular. So we have right triangles with two legs. So to find XY, we would take 10 squared plus 5 squared, and that is equal to XY squared. We get 100 plus 25 equals XY squared. We get 125. Take the square root of both sides, and XY is going to equal 11.18, rounding to the nearest hundredth. And since this is a kite, we don't have to do the math for this next one if we're going to use YZ, because we know that these two sides are congruent and these two sides are congruent. So YZ is also going to equal 11.18. And if we did the math, you could see this side is 10 as well, so we would get the same answer doing the math. For WX, this side, we're going to use side lengths 19 and 10. So 19 squared plus 10 squared equals WX squared. Gives us 361 plus 100 equals WX squared. 461. Take the square root of both sides, and side WX is going to equal 21.47. And again, since these two sides are congruent, WZ is also going to equal 21.47. Okay, now quadrilateral EFGH is a kite. We want to find the angle, the measurement of angle G. So we know in a kite exactly one pair of opposite angles are congruent, and we can see that angle H and angle F are definitely not congruent when we have 100 degrees and 40 degrees, so E and G are going to be congruent. If we remember back to one of the videos in 7.1, interior angles, the sum of the interior angles of a quadrilateral is 360 degrees. So to find measure of angle G. First we subtract 100 plus 40 from 360, so 360 minus 140, that gives us 220. And if these two angles are congruent, that means they're the same measure, so we will simply divide by 2 to give us 110 degrees equals angle G. Okay, now that we have seen the properties of all these quadrilaterals, we're going to be able to fill in this chart, and you can refer back to this later on when you are comparing quadrilaterals. So we have our parallelogram, that's what this one is: rectangle, rhombus, square, kite, and trapezoid. We're going to put an X in the box of the shape that always has the given property. So first property, both pairs of opposite sides are congruent. That applies to parallelogram. And since rectangles, rhombuses, and squares are all parallelograms, it applies to them as well. Both pairs of opposite angles are congruent. That applies to parallelograms, and so that follows that rectangles, rhombuses, and squares have this property. And then exactly one pair of opposite sides is congruent, and that is only true for trapezoids. Then exactly one pair of opposite sides are parallel. Again, that is only trapezoid. Exactly one pair of opposite angles are congruent. That is property of a kite. And consecutive angles are supplementary. That is a property of a parallelogram, so it is a property of rectangles, squares, and rhombuses. Make sure you do your reflection, get online, answer the questions, tell me if you have any questions, and we will see you tomorrow.